In this video, I'll introduce escapement and the concept of video escapement prototyping. Escapement is a novel video prototyping tool for interactive designers where sensors control animations. Escapement is a tool that allows a designer to start from any quick video mock-up of an idea, such as this stock video of clock gears. But instead of just having a video where time ticks inexorably forward, escapement turns it into an interactive prototype. This factors the time dimension out of the video and recasts it as interaction. This abstraction of time, which we call video escapement prototyping, is a powerful concept that allows the designer to rapidly explore and viscerally experience a wide range of sensor-mediated interactions. Here, the sensor-mediated interaction of swiveling the display, or swiping it with touch, or other plausible ways of moving the device. Some of these video clips may be familiar to you from previous projects, including this clip from the Air Constellations paper by Marquardt et al., and this tilting interface by Hugo Romat et al. This project evolved over many years and went through many different iterations. In fact, some version of escapement has been in active use by both novice and expert designers since 2017. Escapement had its origins in one-off demos, such as an opening-closing animation for a prototype dual-screen device. The next iteration was Tilt Video Player, which allowed a user to play back video files interactively in response to a 1 degree of freedom tilting motion, where the angle of the device mapped to the frames of the recorded video. This allowed interactive non-sequential access, forward or backward, as the user adjusted the display up or down. The tool then went through a major reconception and redevelopment to allow two changes. Number one, allow designers to replay videos on multiple viewports running on the same or separate devices. And number two, read sensor data from many more sensors, both built-in, such as the gyro and magnetometer, and arbitrary attached sensors, such as a proximity sensor connected via an Arduino. We additionally added more sensor options, including the ability to filter, define cutoffs, choose input degrees of freedom, demonstrate motion paths by example, and so on. In other words, the escapement tool evolved in parallel with the design needs of the expert and novices who were working with it. We started with a single sensor and a single device with multiple screens, and then expanded to running on multiple devices connected over the network. Now, I'll share more details about the design features of our tool. While the core concept of controlling video playback via sensor data persisted throughout each version of the tool, other features continued to be refined and extended as we developed our concept of video escapement prototyping. This research through tool design process helped us to identify the core relevant design features. Now I'll briefly walk through 4 of these 6 design features. Number 1. Using time as a design material. By first pulling time out of the videos and then providing tools to manipulate this abstracted time dimension, escapement enables designers to engage with time as a first-class design material. For example, escapement allows designers to easily time reverse a given video sequence. Thanks to this functionality, created or recorded videos can be quickly remapped to different sensors or different degrees of freedom, while maintaining stimulus response compatibility simply by reversing the video playback. This design feature also contributes to escapement's bricolage style use of found video, because instead of requiring an extensive video editing workflow, designers can simply tap the reverse playback button. Number 2. Manipulating video in a conversational and, number 3, embodied way. As designers physically manipulate the devices, they engage in reflection and action, a conversation with the video materials available at hand. They learn by doing, and develop an embodied intuition for the designs being explored. Escapement is an example of a tool that supports design by inaction. Specifically, our tool allows designers, developers, and any other users to have an embodied experience with a particular design in context at an extremely early stage of the design process. For example, a user may tilt the device down to provide a more comfortable writing posture, yet once enacted through video prototyping, Other ways to leverage this natural tilting action, such as automatically revealing pen colors and mode colors, more easily come to mind. And lastly, number 4, rapidly exploring different sensors and degrees of freedom. As part of the iterative creative exploration process, designers may want to reuse a single animation, but try mapping it to different sensor inputs, or different degrees of freedom, or across different devices. Designers can experiment with sensor input modalities and explore whether direct touch, indirect, relative mouse input, or embodied tangible tilting or any other device movement feels the most appropriate to a given interaction. I'll now discuss some of our findings in the context of existing literature. As designers of creativity tools, we are always interested in creating new paths of least resistance that support creative practitioner values like dynamic responsiveness, quick start, the ability to rapidly begin engaging in design activities, and experimentation, or extremely tight loops between making a change to a system and seeing the resulting change. Increased expressive leverage, or enabling designers to achieve more with less, and expressive match, or close alignment between tool output and designer goal. As we've seen over the last 3 years that escapement has been in use, this tool has evolved to provide these expressive capabilities. One impactful aspect of escapement is the way it allows designers to experiment with the same or new interactions across different layers of scale. Simply by running the viewer on different devices, the designer can explore the same animation on a single mobile device, multiple connected tablets, a large desktop monitor, even large wall-scale displays or electronic whiteboards, increasing both in number of devices and screen real estate. This flexibility, an important aspect of any novel design system, is particularly valuable as HCI as a field necessarily moves towards supporting cross-device interactions, like those identified by Brudi et al., Marquardt et al., and Yuan et al. In recent papers. Tools like escapement allow designers to rapidly scale their experimentation up across such diverse device ecologies. The same video can be repurposed and experienced for each of these use cases, allowing for extremely rapid, highly contextual, embodied exploration with the particular sensors, input resources, and display dimensions of each specific form factor. Interaction types. Hartman refers to 2 types of animation playback as a function of input. One-shot animations, which play after an action is performed, such as pressing a button, and user-in-the-loop behaviors, where continuous input drives the behavior. Escapement is not designed for one-shot animations that play once an action has taken place. Rather, the video responds while the action is happening, much like everyday life, which is analog and continuous. We feel that there remains much potential in exploring and bringing such nuances to digital experiences through continuous, analog, sensor-mediated interaction techniques. As part of our goal to empower designers with new capabilities and fluid design exploration, we have introduced escapement-style prototyping, embodied in our tool, Escapement, that leverages recorded video in a bricolage process as an interactive design material, allowing designers to rapidly generate multiple alternatives and explore their implications across one or many devices through an embodied conversational design process. Thank you so much for your time, and we look forward to seeing how future designers use escapement-style prototyping in their tools.